Hello and welcome. So this is our third session. We are taking VMs from wherever they start, often in VMware, and moving them over into cloud native, into that cloud native space so you can be part of the future. I'm joined, as before, by David O'Dwyer. David.
Hi, I'm David O'Dwyer. I'm the director of a cloud infrastructure modernization consultancy called LiveWyer.
Now, this is the third session, but there's no need to worry if you missed the first two. We were really setting up the tooling in the second session and the why in the first session. But if you're already here, you probably know a lot about why, and you can jump back into those sessions. Now, we were expecting to have a lovely chap named Temi join us today. Unfortunately, Temi's been pulled away. We're disappointed he isn't here, but indeed, I used to be a Temi. Temi is a solution architect at Portworx, and that's my former role. So I will take you through all of those pieces as we go in today. So today we're getting into getting you started and showing you how to get it working. And we're exploring the case studies and pegging out what a proof of value could look like, what it costs and what savings could be, to say nothing of securing the technical future of your team members and to some degree your company, because we have to remember that software delivery predicts organizational performance. That's from Accelerate and Nicole Forsgren's work. A quick recap of the state we're moving into. So more than half of VMware customers are looking to move, and 44.9% are looking at migrating to open source solutions. And it's reported that Broadcom are moving big fish and they're moving away from the small fry. So the strategy appears to consist of ditching those smaller accounts. Now, AT&T reported famously a 1,050% increase in their VMware costs. So that's fine. If you want to look at what you're moving away from, that's often the case. But really, as people, we want to look to a better future, right? Make our lives better, how we can feel more empowered as engineers, as organizations making use of technology. So let's look at that. The CNCF reported that containers per company doubled from 2023 to 2025. So this is really exploding. And if we look at other technologies that are really emerging, right? Everyone's talking about AI. Well, Gartner predict by 2028, 95% of AI will be run on Kubernetes, right? So you want to align with the future, you want to align with AI, you want to move away from the legacy, but you want to allow that to continue to some degree, then this is the place to be. I want to take you through a little bit of a timeline because I was teaching an infrastructure team recently with David actually about how Kubernetes has come about. And what's really apparent from this slide is that the technology, although there have been iterative changes, doesn't really have anything to speak of that's significant since Kubernetes came along. So if we look down toward the Linux containers being released, those were in 2006. As Docker was released slightly after Hyper-V was released, right, there's nothing really else to report. So all that innovation, all that control, all the building of systems as they've exploded has focused on the container space in that time. And this is very much part of your work and your consultancy, right? This is where it is.
What we found is traditionally containerization is coming in when there is a new infrastructure need, and they've found that the VMware or the VM space is not adequate for that development to be successful. So for instance, there's certain types of development workflows, there's a need for certain types of ephemeral environments, there's a need to distribute and scale quickly. We've seen containerization coming to that area at pace. What we've also found is that there's customer needs, so their customer demands. So one of the big driving forces has been where they have traditionally developed their software applications to run on a VM basis, but now their customers are requiring it or want it within a container basis. So they're having to reproduce their software stack within a containerized environment to then meet those customer needs. But even in, say, a more traditional VMware environment, containerization is typically happening anyway. It's happening on the layer above. So there's always been this separation of concern where you've had operations teams managing that VM and VMware real estate, but they've not necessarily had the or the management or the operation on the layer above. And so we found a number of organizations that typically you've got small greenfield projects. It's fine. Developers have their own little areas. They're working in their little teeny real estates. Everything's fine. The moment it gets serious, now there needs to be proper operational controls. There needs to be a centralized team managing this and scaling this. And for a number of organizations, they look towards their traditional operations team. So we're finding that containerization isn't something that's about to happen for these teams. It's already happened.
But you've got a container situation rather than a container strategy quite often.
Exactly. And we found this when cloud computing first came on the scene. It's already happened for these organizations. So let's take a traditional VM space, and I want to get an IP address for a new VM, and it's going to take me 2 weeks to get an IP address that I can sign off to get assigned to it. This is where public cloud thrived in those spaces where you had developers or departments with credit cards setting up small accounts, and now suddenly these teams are enabled. They're moving quickly. They're moving at a different pace to the rest of the organization, and they're getting things done. No one says to stop and slow down. Let's put some operational oversight on this thing that we really need you to develop quickly. But what happens is it gets too big to fail. And now, like you said, you have a situation where suddenly now that operational team has to adopt the public cloud, is now adopting VMs in the cloud. And for a number of organizations, that's happening, will happen, or could happen within the container space. How can you accept that? And how can you take this opportunity that's been presented in terms of a replatforming, redeployment, and how can you use that to your advantage to take control over what is already happening?
Can you give me, like, on a scale of 1 to 10, how easy is this to do?
Basically, I'm fed up of seeing presentations that say that this is easy.
Right. Why isn't it easy?
It's not easy because it is going to the very foundation of how organizations run and manage their hardware stacks. And that's not easy. And
changing people is harder than changing technology.
And I've seen a number of presentations on this. I've seen, obviously, as part of us building our product around this in terms of helping organizations make this move. And the vast majority of them, what they'll do is they'll flash up some form of UI. They'll click a couple of buttons in the browser and they'll fast forward, which is fine. Fast forwarding is fine. No one's got time to spend half an hour waiting to see a bar go across. And it's done. It's just done. It's just done. But it's not. It's not done. It's not done. That may have completed one segment of the work. And I think it's really important for organizations to understand, regardless of where they're moving to, if it's Kubernetes, if it's another vended product, if it's another hypervisor, that this is not a simple point and click operation. This goes to the bowels of understanding your real estate and understanding and actually having to interrogate your real estate and having to interrogate and surface up all of the unsaid work. And I think in a number of organizations, there's a huge amount of unsaid work. And so with all the best intentions of all the best architects coming in, and they see it at the same surface level, they see it based upon what they're shown or what they're told at that high level, they can convince people and convince themselves that this is going to be a straightforward operation. But the reality is, once you start doing these projects, they're not. And you have to accept that complexity and you have to embrace that complexity up front. And it has to be part of the process. It has to be part of this work.
When you go in and help people see this new way of operating, how do people normally feel about it if you're talking to infrastructure people?
Scared. Honestly, I think it's that it's an unknown for a lot of people, and I understand why. And I think working in tech, there is so much that you have to keep up to date with and understand that it's very easy for you to put some partition into areas which are what you feel is a large step beyond what you're doing at the moment. So one of the first jobs we do when we go into these places is that we try to find the common ground. And within VM space and within the container space, there's huge amounts of common ground. Very much it's the same work. The way that we look at this is, yes, there is a modernization, there is a migration of the technology, but it's also bringing the team along with that as well. And yes, there will be skills that need to be learned. There will be processes that will change. But the real core skills, the real reason why these people exist in those roles, to be able to operate, supervise, manage, troubleshoot, all that is still relevant within this new ecosystem. And to be honest, more so, because if you are taking the journey of moving those workloads into a microservices or container-based workload, you need to understand what the operating state was originally more than anything else. You need to know what good looks like, and you need to be able to translate that into a more modern framework.
If you were to bring in a new skill set, you lose that domain knowledge.
Exactly.
And that domain knowledge makes those non-functional requirements of your application work.
Well, the way that we've always looked at infrastructure has always been there's sort of good path and bad path. Yes, you can hire people who have a lot of experience of good path operating within a certain environment like Kubernetes or within any of the other sort of vendor products out there in this space. But that will only get you so far. Because once you have a systems event, which will inevitably happen, or you need insights, or you need to push on new innovation, new performance, new environments, there's constant change. When you need to move into that area, that's where you need the key insights of people who understand what bad looks like and what the problems have been in the past and what the legacy of it, what the profile of it is. And so having those people in that space and giving them the additional information and training to move into that space is hugely valuable, far more valuable than bringing someone, say, from the outside into that space and then trying to somehow teach them decades worth of legacy information around that application stack.
So I'm going to talk abstractly about the stack that we're going to use for this, because what we're doing is we're often moving from an island of containers, right? In Kubernetes or running on virtual machines in a Docker setup. Sometimes they're hemmed into one virtual machine, right? And we then have this separate island of virtual machines. Yeah. As we're looking to move forward, we're cutting out the VMware hosting aspect of it. We're mostly moving that to bare metal. Now, for the sake of a POC, you don't need to move things to bare metal. You might have some big hosts. There are 8 terabyte hosts out there, right? You're not going to do that. Until you're at scale, then it makes a lot of sense, right? But what we're looking to do is put a stack underneath. We use KKP. If you've got something already in place, we can use that. And then we're going to run the virtualization in there. And that's going to be in the same sphere as Kubernetes itself. So these become a virtual private cloud where you can mix virtual machines and containers and then use Kubernetes' power to avoid issues. So going back to those non-functional requirements, the constraints that occupy a system's context, we have requirements for DR, we have high availability, we have recovery point objectives, all those pieces. In a standard KubeVirt setup, what happens when you have, a node tied to its storage, or perhaps you have multiple nodes tied to a single piece of storage? What happens when there's a failure? Just to illustrate the value of port work.
One of the biggest challenges is if you've got read write once, which is where you've got this situation where the platform simply will not attach the storage unless it has confirmed that the storage has been detached from the previous. And in those situations, that's where you get, the VM will come up eventually, but you get these delays because the last thing you want is to have storage attached in 2 places. That's where you can get horrible situations, split brain situations where you can get data corruption. For instance, when dealing with AWS, they go to great lengths to ensure that you simply cannot attach across 2.
Yeah, in AWS, they just nope out of going multi-availability zone with storage. So your storage is tightly coupled to an availability zone, which somewhat undermines the whole principle, right? You end up then being incentivized to putting everything in one availability zone because then you don't have 2 failure domains. And when you put 2 failure domains together, you multiply them together, right?
Yeah. And it really does push the burden when it comes to data replication onto the application level. So they expect you to handle that data replication within the application stack itself, which is doable. It is quite an operational overhead and quite a leap that needs to be managed.
Yeah, and you consider that moving into containers, typically IBM says 80% of the resources. That's infrastructure and effort, the operational effort. If you can bring those things in faster, you can really make a business case to make savings there.
So the second scenario I want to talk about, which is around the idea of live migration. So this is, again, something that a lot of VMware infrastructure engineers will be familiar with when they've got the vMotion and other sorts of capabilities within the stack. So typically what happens within a live migration is that you're taking more of a maintenance event. So this is something where we want to drain the node, we want to drain the server. So we want to do some maintenance on it. So we want to move all of the workload off of it. So in that scenario, if you've allocated the live migration strategy or live migration setting to your VM, what it'll do is it'll pause any actions that Kube is taking, and it will then essentially spin up a copy of itself on an alternative node whilst it's still running. It will then transfer the memory state across, and it will keep transferring across. And the moment that the two are in sync, it will switch over within about 0.1 seconds. It'll be switched over. Now, that strategy only works really if you have something like Portworx, which allows you to have read, write many, the ability to have both attached to the same storage at once. So those sort of live migration strategies is when really having a sort of a robust storage layer really comes into its own.
There are a few particular compliance requirements that have entered the frame in the past few years. With regards to the CRA, the Cyber Resiliency Act, if you're running VMware today and you have perpetual licenses, VMware are going to push you into consuming their licenses with new service bundles. And you cannot stay on the perpetual licenses because it's butting up against the CRA's need for resolution to issues in a timely manner. So that becomes not something you can do. And then when we look at DORA, we're looking at how we make your applications move into a working state from a state of failure in a very concise time frame. So the fallback on that is 2 hours. Your application, your workload, your clients, to avoid an issue that is of note, may be smaller than that. And we have solutions within Portworx that allow you to do that. And we have mitigations as well within Kubernetes that mean that no one's even going to notice that there was a significant failure.
So let's talk about the how. Let's talk about the demos.
So these demos are compressed. We want to show you what works, not how to work it. So we'll put links in for the longer form demos so you can fill your boots and see it in much more detail. So demo 1 is old vert to new vert. So taking it over to KubeVirt across a WAN. And we're going to show you how to use some open source tooling on that to get you across into this Kubernetes space. Demo 2 is where we take that migrated workload and explode it out. So portions of it are within Kubernetes itself, and the state lives within a virtual machine. Now, Redis is the example we're using. Redis goes quite nicely into Kubernetes. But if you wanted to run, MS SQL or something like that, which doesn't play so nicely, that's a pattern you might find yourself having to take while the software vendors catch up. So let's drop into the first demo. Our VMs will start in vCenter, and we're doing a warm migration, so minimizing downtime for the cutover. We'll gather the config and give it to Conveyor, which is automation for KubeVirt, and we'll kick off a plan for KubeVirt, which has several stages, starting with the virtual machine's data. Once in place, we turn off the original virtual machine and do the last copy of the delta, convert the image to a KubeVirt format and remove the VMwareness. Bring up the VM and make it at home in its new virtual private cloud. So let's see how that's done. Starting in VMware, we've got 2 servers, a front-end server and a back-end server. And what we need from those are the IP addresses, and we'll take those and put them in our config. We're going to use fork of Forklift for this. Our front-end app servers are running in services, and you can see the ports and processes here, and these packages are ripe to be containerized. Our back-end server is running Redis database and other back-end services like payments. So let's monitor Redis while we look at the app. So this is our application. It looks retro, right? And we can do some e-commerce. And we can see the database actions. So let's migrate this app. Forklift is a tooling we're going to use to warm migrate these VMs. The custom resource lets us pull the necessary details into a managed object reference ID for Forklift to move the VMs. It includes the VMs, the data stores, and the networks. We do the same for the backend servers. Let's apply our config to give KubeVirt access to vSphere and check that those aspects have made it into Kubernetes. We'll create the Forklift resources on the cluster. And then we can check we've got the provider, and we can check we've got the storage map, and let's look in there as well. And here it is. We can see the storage class is Portworx replicated, giving it automatic high availability like vSAN. Next, we're looking at the network map. That's present, so let's look inside. And this is all that we need today. Now we're going to plan the migration. The resources are ready, so let's check the plan for the front end, and we can see the resources we've spec'd out, the network and the storage maps, and at the bottom of the events you can see we're waiting on some aspects to be ready. Same again for the back end, but this one's reporting ready already. Let's apply our config and note that Kubernetes is declarative, so you tell it what you want and then it decides how to do it, and there is no progress bar, but we can monitor it with commands, and this seed copy is underway for the VM, and we can interrogate the status, and we'll follow on the front end only here. We can see in the middle the migration initialization is completed, and we can see the destination pod is running and the delta cutover is to do. Later we'll finalize the transfer and create the KubeVirt image post-migration. The data volumes are importing using a KubeVirt custom resource because Kubernetes is extensible, and we've got the persistent volume claims. We can dive into the logs to see what the importer did. We've overlaid the vSphere status here. It completes. We're checking on those data volumes. Our data volume made it. Next, the cutover. Let's check the vCenter for the VM. Our front-end server is off in VMware. Forklift called a shutdown to get a complete copy. The original data copy took about an hour. This stage takes 5 to 10 minutes as we're just copying the deltas, then bringing up the VM. We can see the progress in the migration object, and the cutover has completed, and it's converting the KubeVirt image. Let's see if our VM is up, and we can see the front-end pod is running. A pod is a deployment in Kubernetes. Our data volume is present, and it's tied to a persistent volume. Think of an OS on a USB, and that's plugged in with a persistent volume claim. Here we're looking at the runtime logs of the VM that's being converted, the standard out. At this end, it'll be the KVM compatible VM. We fast forwarded this. At the end of this process, it shuts down the VM. The front-end plan is complete. So let's see if our VM is ready. One more check to see if it's running, and it is. Has it been plugged in on the virtual private cloud? It has. So we get the full VM details, cores, disks, RAM, MAC address, persistent volume claims, etc. We repeat this process for the backend VM, but I've skipped that today. The VMs are now up. They've got their old host names in place, but we've got to make these resolve in their new virtual private cloud context. So we configure the networking to allow intra-VM communications. Naturally, we do this with config. So here we are defining the interfaces for the front-end server. We're using the cluster IP and a port to allow testing access to the VMs. We apply these configs. Notice that they're all in the folder, so we don't call them individually. We can see that the services are now visible, the internal ports, service names, and a single external node port. We create a virtual port forward so we can test from our local system. And we're back in our retro gaming store in its new location, but we've escaped VMware, which feels a little bit retro now too, doesn't it?
Hi, welcome to our second demo for this session. Today we will take the store front-end application and transition it from a VM into containers whilst maintaining application uptime. Our aim is to focus on a few of the key aspects of this migration to give you a little flavor of what Kubernetes can offer in this space. So, focusing on the diagram, our end goal is simple. We want to move the applications providing cart, add functions, etc. out of the VM and into a container or pod in our new terminology. Each of these containers will be given a label, more on that later, and those containers will have IPs or endpoints associated to them so that we can send traffic to them. We'll run both sets at once and show how easy it is to move traffic from VM to container. And to finish, we'll highlight a key benefit of running stateless applications as containers. To pick up from the end of demo 1, we saw the VMs live migrate from VMware to Kubernetes. And as this is an accelerated session, we're going to go and rejoin where we have rendered and exported that workload as files so that we can edit and reapply them as needed. So as you can see, we have already containerized versions of our application stack. In a number of instances, you'll find that you'll be taking existing containers rather than having to re-engineer them all yourselves all the time, such as Nginx. Moving on, an important aspect of moving to containers and Kubernetes in general is the use of infrastructure as code, or simply configuration language as our standard way to interact with our infrastructure. Here we can see one of the rendered workload files we exported and configured from our system after demo 1. Here we can define all aspects of our workload, such as network, storage, environment variables, and it's here that we introduce all of the container configuration alongside our existing VMware-based front end. So as we apply our changes, we're introducing the new containers and the new storage and the new network configuration all under a single operation. Application code has not been changed at all during this period. We've simply applied a new modern way to deploy our infra. For the purpose of this demo, we applied it all in one command line, but most systems these days will use robust pipelines that do checks and validations. So here you can see our pods are running ready and available, and they sit alongside our previous VM. At this stage, with testing and confidence, we could have switched from our VM to containers as part of our single workload update. But we instead introduced parallel network configuration, which allows us to have coexisting and testable endpoints for both VM and pod deployments. So to summarize where we have containerized our workload. We have added those containers and their associated network and storage to our existing workload configuration file. We have applied the file on the command line with a single command. The system has reconciled and applied our changes, and now we have our VM running alongside our container pods, with each one running a further function of our front-end application stack. So now we have things running. Let's focus a little bit on the networking. So Kubernetes provides an extensive network capabilities that offers administrators a sophisticated set of tools. Consider the service resource, essentially a software load balancer that receives traffic and distributes it across endpoint. Our front-end service uses a selector label to route traffic to endpoints bearing that label. Currently, it points to our VM label. Why route to labels rather than direct endpoints? The answer lies in resilience. VMs and containers can restart or fail, causing endpoint addresses to change. However, the service maintains a static endpoint for applications to reference. By routing via label resources, automatically reassociating themselves with the service whenever they recover. While our containers are running with a different labels, the transition process is remarkably straightforward. To go live, we simply update the service resource label from VM to pod, such as this. I feel this approach is a great example of how Kubernetes delivers the benefits of dynamic systems while maintaining the predictability and interfaces of traditional infrastructure. And here we can see the static service endpoint is now pointing to our container pod label. And now to do some tidy up and edit our configuration again. But this time we're going to retire the front-end VM. We simply delete the configuration associated with the VM from our configuration file, like such. And we apply it again on the command line. We then confirm our container workloads are still running ready. And we confirm the container endpoint IPs are still available, but the front-end VM IPs are now gone. And finally confirm only the back-end VM is remaining. So what does our final view look like? So we have successfully migrated services from a single VM to multiple pods while maintaining our legacy back-end VM, all running on the same infrastructure. Front-end services, cart, checkout, and front-end components are now distributed across 3 servers, scaling independently based on demand. The switchover required a single manual command, though they could seamlessly be integrated into automated pipelines. The stateless nature of our front-end application enabled migration without extensive data management requirements. For scenarios which do require persistent storage, such as the back-end VM, we would leverage storage capabilities provided by data providers such as Portworx. And on that final point, A more comprehensive version of this demonstration, along with demo 3 covering stateful migrations to fully containerized workloads, will be available soon, where we go into a much more technical deep dive into those subject areas. But for now, that's the end of our demo, and I really appreciate your time watching.
So I wanted to give you a case study. Now, this case study will be going live with the customer's name in a couple of weeks, but for now I have to keep it abstract. So this is a national European telecommunications company, and in 2024, they started to look for an off-ramp to VMware due to concerns about what Broadcom would be doing to the costs. And their stack was built on a VM-centric approach, specific VMware-centric networking, sounds expensive, specialized storage that could be managed by those hypervisors too. And they were really a VMware shop. It had been working for them, but times changed, and they knew what served them in their earliest success was going to hold them back going forward. They didn't want to move from one old paradigm to another old paradigm, as you were saying earlier, David. Mm-hmm. But what about their tech stack and their support teams? Would they need to move their thinking and rehire, or could they just retrain their entire team? Would they need to throw out that old hardware? The vision this customer had was towards the horizon. What they wanted was a platform that could cater for the old, but thrive with the new. They could see the direction of travel. Software being released as COTS is very common now. And Kubernetes is becoming a delivery mechanism, as we talked about in the earlier sessions as well. So the options they had was pay VMware their hiked prices and not know that if these were going to increase the next year, or move sideways to another equivalent technology, but have more of the same. So the result was they selected Kubermatic to move the stack ahead. Kubermatic's KKP was selected. It had opened up edge use cases, overheads in efficiency, and that's through sharing control planes between clusters, and also cluster democratization. So everyone who needs a cluster can get one and not step on anyone else's toes. So they got their savings, they avoided that vendor lock-in, and they got the integrations across the Kubermatic and Kubernetes suite. It was easier for the people to be unified on that platform as well. Right, so we don't want you to leave here today thinking that this is some hand wave of what can be done. If you can give a couple of engineers, right, 2 FTEs, and work with a partner like LiveWyer, then we can start to prove this out for you for your workloads. So what might that look like, David?
Well, typically we look at this as a sort of 3 to 4 week pilot program. 2 engineers from a company like ours and 2 engineers for the company that we're collaborating with. Now, that first week is very much information share. It's really important that we have a really good idea of the sort of workloads, the challenges, the sort of technical assessment. And then what we can do is we can make a decision on what is the best application or service that we will use to sort of champion this and use it as part of the actual pilot migration. One of the other things we do is we set some targets of this is what we expect. This is our definition of what good looks like in terms of the application profile. And then we get to work on building a target environment. So some companies will already have Kubernetes in there, but if not, we will go in and we will stand up a Kubernetes environment within their infrastructure stack. The second week is very much a sort of iterative process of working with the FTEs to then start to build out a single pipeline or a single thread for this designated service, and really going through all of the hands-on technical work to get it within a Kubernetes and KubeVirt environment. Then what we're doing all throughout this process is we're obviously documenting everything, because everything is learning. So we document everything, technical challenges, but also importantly, the process and some of the knowledge challenges within the organization. And that leads us to the sort of 4th week where we're very much giving a sort of an overall assessment. So we're giving someone a tangible, practical environment. We're giving them code, so everything that will be done will be generated as a code base, an assessment of the overall success of the project, hitting those target goals. But then more importantly, we're giving them the ability to make their next decision. And we're there to help support them in that decision. For some companies, they're interested in demonstrating how they can run multiple of the same VM, or they have a fleet of VMs, and their target is they want to understand how those VMs are going to work in various failure scenarios. For some others, it's simply a matter of, will this work within a containerized environment? So some workloads have sensitive networking requirements. And so it's actually a very simple, elegant workload. It's not very complicated, but what the service is actually doing and its needs on the hardware underneath is what they want to pilot. So it very much is customer specific.
And we're we're then drawing up a plan as to where this goes.
Yep.
So that we can highlight that journey for you.
The goal of the pilot for me is, yes, we are creating new stacks of technology. We are installing things. We are creating some code to do all this and demonstrate this is how it's done. But ultimately, the goal is to provide a report which contains enough information for an organization to be able to make the next decision. The decision may be that the migration into Kubernetes isn't applicable at this time because the workloads are not ready, or there's too much resilience on legacy workloads which are too sensitive to those environments. But for the vast majority of organizations, it will be the proof that they need and the confidence they need that they can make that next step of the journey into a more cloud-native infrastructure landscape.
As someone who enjoys teaching, I really like Bloom's taxonomy as a model. I don't know if you come across this. At the bottom of this pyramid is remember, and then above that is understand and apply. Now, the proof of concept, we're looking to show it works.
Yep.
Right? We're asking them to remember the terms and understand those pieces. Longer term, we want to make sure they can apply it themselves. Right?
100%.
And this is really the ethos of your company, is to help people become self-sufficient, right?
Yes. My organization is very flat, very technical, and you would call us a boutique consultancy within this landscape. And that's because our method of working with companies we don't want to turn up with 30 engineers and basically own the entirety of the project and then walk away with that domain knowledge. Our goal is to turn up and provide the right level of expertise that bridges that knowledge gap. And very much we feel that a lot of this work is about a knowledge gap. It's not about completely brand new roles or completely brand new domains for the respective teams that we're working with. It very much is a job of bridging their existing knowledge base with, say, positioning of that knowledge within the Kubernetes space. So what we will do typically is we will go in, we will help, we will upskill, we will invest heavily in documentation, heavily into mapping and understanding that space. Our goal is then to ensure that the customer has a very clear roadmap of what that journey is. We have a clear understanding of what our engagement with that is, and we have a very clear understanding at what point we're both happy for us to exit from the project and allow that company to proceed.
This is a unique time, isn't it?
It is a very unique time. If you go to many companies and ask them, do you have budget to review the current infrastructure, architecture, review the current landscape, review the way that things have been done for the last X years and invest money heavily in maybe correcting mistakes of the past or making improvements which don't necessarily lead to direct performance improvement or some other cost benefit. Most organizations wouldn't necessarily put the budget on that. For a number of organizations, there is a budget allocated to this migration and this move. I think it's a real opportunity for organizations to not just look at it as a budget to get the same, but a budget that can really move an organization's infrastructure and team and opportunities forward.
So there's a lot of expertise coming in, a lot of show me how to do this. And the cost, there's two different costs. And all the costs include the engineering and the licensing.
Yes.
For 30 days.
That's correct.
Now, a pilot can be extended out to up to 90 days.
That's correct. And we found in certain situations where we've said we want to pick a designated service or there's a couple of services. Sometimes for some organizations, a single service doesn't make sense to them. Again, that definition of working, definition of good expands out over a service which has 5 components or 10 components. And we need to move all of those together for them to be able to get any real insight into if it's possible. So in those situations, we do extend out the implementation stage. But again, the actual engagement from the stakeholders and from the more senior members of staff is still the same, we find, relative to if we're doing a 30-day or a 90-day engagement. We typically find that extension is purely on a technical basis only.
And if you've got enough Kubernetes ready for this, then the price of doing this is £20,000.
That's correct.
If you need Kubernetes setting up, then it's a bit more work.
Yep.
But it's that comes in at £30,000. The licensing is expected to cover 3 nodes typically.
Yeah, typically 3 nodes.
And there's a pilot to production package, a lot of P's, that can be put together, but that's bespoke. We need to understand the non-functional requirements of that at the time.
Exactly. And I think one thing that's important here is that the information held within the report is not centric to LiveWire or indeed Kubermatic. It's centric to their workload with a KubeVirt and with a Kubernetes destination. It very much is giving them an opportunity to understand what that looks like, hopefully with our organizations, but equally without our organizations.
Yeah, there's some market leaders who have open source, but it's very bespoke,
Yes.
not very compatible, and you can't just get up and leave. But everything we're talking about here, it can be swapped out or adopted using completely open source technologies. Right? We also got an illustration of what this costs to run longer term. And of course, as we add in longer terms, into the years, 3-5 years, we can get those costs down per node. And of course, the more nodes you add to this, the better that price can be. So that's really a high watermark on the costs of doing this. And if you compare that to the prices you're seeing with VMware comparisons, it's quite competitive. When I look at quoting Kubermatic, because we don't work in a vacuum, against other providers, we've come in about 45% of the total cost for some of the headline providers that we see in the market. And then if you consider the reduction in overhead, as we look at something like KKP, you come down to about 60% saving on the total infrastructure cost. So I'm certainly happy to discuss that with your bespoke needs. But at the end of a process like this, we're going to understand a lot more to work out how that might look and what savings we could get you from that broader estate.
Okay, we've got some questions about the demo. So I believe, David, you got some over chat.
In relation to what's the biggest paradigm shift that teams moving over from VMware have to contend with? And that's an interesting one. I think the major issue is the mental model. The mental model changes between what I think we've discussed this on one of the previous sessions, where you're going from a sort of imperative command-driven to more of a sort of declarative intent-driven spec. And, moving from something where you're saying, do this, it does this one specific thing, you wait 30 seconds and you can get lots of stateful updates and then it's done, to a system of eventual consistency, where you're essentially saying, this is where I want you to go to, and then the system converges. And during that period of time, things may be failing. Things aren't ready. Things will restart, things are trying, but the idea is that all of these loops of this end state are occurring, and when dependencies are met, then it will be eventually consistent, and then you get what's known in Kubernetes as a sort of running ready. I know when I first used, many years ago, when I was first interacting with Kubernetes, that was one of the biggest problems I had. If I see something that says error, I want to jump. If I see something say it's restarting or there's a problem, I want to jump in. But actually, this could just be workloads trying to access a dependency, such as a database or something else, which just isn't started yet. And it will restart, and it will restart. And then at the point at which the service is available and it connects, it will report running ready. So what you're seeing is that these sort of declarative workloads transition from unavailable to available to available to done. So I think that was one of the sort of biggest shifts. I mean, there's some other things away from that, which is interface. So you're moving away from predominantly like a graphical user interface, although, a number of Kubernetes products such as Kubermatic provide, very versatile UIs to interact with. There's still not really much getting away from interacting from the command line. Now, I will say with KubeVirt and the options that provides, it does provide low-level tooling. So I know I've said imperative is shifted. There are still imperative actions, especially around KubeVirt, where you have the ability to use the virtctl command to do things such as stop, restart, shut down, these sorts of interactions, things which VMware users would be very familiar with. But yeah, hopefully that's answers the question.
Makes perfect sense. A question we've had is, what are the recommended steps to be taken to prepare for a migration like this? Of course, you don't just turn up on day one and get going. So, David, I wonder if you could share with us that one.
For this, my recommendation would be prioritize inventory. I mean, you have to know what you're migrating. There's a lot of work that happens before any interactions with Kubernetes or KubeVirt. And I think the action of going through and doing a clear inventory of VMs, understanding the types of workloads, criticality is important. But things such as resources, dependencies, another interesting one is licensing, establishing some performance baselines. If you have those numbers, understanding what essentially good looks like. Because moving over the VMs individually is all well and good, but you need that definition of done. You need to have the definition of working. So it really is there's an element of auditing involved. So that's one stream I'd recommend. The second stream is to pilot. So essentially what we're talking about today, which is to set up a small, take a target application, target VM, one which will give you the most information, the sort of the most surface area of information. So it may not be the most complicated, but it may be either the most read heavy or critical or vulnerable, or could be the most brittle. And if you can get that across, then the other applications will fall into place. Whatever's going to give you the most information. So I'd focus on that, or a few dependencies around that as well. And I would go through the internal actions of actually going through the either the KubeVirt, the forklift process, as we've seen in demo 1, or or if you have a relatively uniform real estate, then do it in a more programmatic way in which you can actually generate these assets yourselves and then be able to then launch them en masse, and then go through that process and get the learning from that. You'll find that a lot of the learning from it may not necessarily be technical. It may be internal process. It may be more structural. It could be to do with the silo of information that you have to gather, the sort of information dependencies that you have. But this is all really good information to understand what it is that you'll be doing in a slightly more larger and robust scaled operation. So that's what I would focus on.
Very good. Yes, it takes some forethought to get these things underway, doesn't it? But the inventory is the one I see most often. People really struggle to get a handle on that.
I hope this journey has been useful to you. If you've got any questions, you can find us on LinkedIn and we're happy to answer them. Do get experimenting. And remember, it's always about culture. There's always that challenge with awareness and getting people to change. So I recommend you look at something like AdCar there. But it's been a blast talking to you all. You take care.
Thanks very much.